Hey guys, so today's video is about data and statistics and graphs and data distribution on those graphs. So I have an example up here on the board. It's about test scores. So let's say you were in a math class and you took a math test and 3 people got a 71% on the math test, 4 people got a 75%, 8 got a 79%, 9 got an 86%, so on and so forth. And you want to try to find different ways to represent these numbers visually, like on a graph. So I have up here 3 graphs that all represent this same data differently, and I want you guys to pause the video for a second and take some time to figure out kind of the similarities of these graphs, the differences, what they represent, what patterns you might notice, trying to figure out what maybe they're good for, just basically how they represent the numbers and how they're different from the other graphs. Okay, so you might have noticed that this graph right here has a bunch of dots, and they each correspond to a person. So this graph is really good at telling us the specifics of what each person got. You can really see that, okay, 3 people got a 71%, 4 got a 75%. You can just look at it and it kind of tells you the distribution. You can kind of see a curve along here. It's really good at that kind of stuff. But you can't really see much more than that. You can kind of just see like the bare numbers. This graph right here, though, is kind of funky looking one. You could have noticed that this line and this line correspond to 71% or these 3 dots, or 97% in these 3 dots, which are actually the upper and lower kind of values of this data set. So these lines on this graph actually represent the range of this data set. And you might have also noticed that there's a line going through the middle of this box right here. And this line is directly over this 86% with the 9 dots, or the 9 people here. And this value turns out to be the median of the data set. So the median is the middle number of the data set. When you line up all the data from least to greatest, it's the number directly in the middle, or if there's 2, then you take the average. But it is 86 in this case. And the edges of this box correspond with this 92% and then this 79%. And you might have noticed that I drew little stars here next to this dot and then also next to this lower dot. And those are the medians of the upper set of the data set and the lower range of the data set. And that's where these lines are. These lines represent the median of the upper range and the median of the lower range of the data. So because this is the median of the upper range and the lower range of the data, then this box in here is going to be 50% of the data, meaning this little space right here is going to be 25% of the data set, and this space right here is also going to be 25%. Even though these look different, that's good because, well, I mean, it's not good, but it tells us more information because it tells us about how the data is distributed. So yeah, this graph is good at telling us what the exact numbers are, who got what, or not really who, you don't know any names, but the people that got what. And this graph is really good at telling us kind of the median amounts, the range, the just where the data kind of falls in this graph. And this is a histogram right here. So you could have noticed that the line, or the numbers on the bottom go 70, 75, 80, 85, like that. There's people along the y-axis, just like there are for this. And also that the bars in this graph go between the numbers, so from 70 to 75, 75 to 80, like that. And that's, I think, the most important thing to notice, because that means that this bar right here, this 3 people, this corresponds with the 3 people that got a 71%, just like these 3 people got a 71%. You could have also noticed that this goes from 75 to 80, but there's 12 people there. So here's our 75, here's our 79, 4 plus 8 is 12, which is why it's like this. So this graph right here is really, really good at telling us kind of the ranges in which people score, or the ranges in which people fall. And the way that this graph looks is all dependent upon the kind of spacing between the x-axis here. Like if this was from 70 to 80, 80 to 90, 90 to 100, and those were the only ranges that we had, well then this bar would be 15, right? Because 15 people scored between a 70 and an 80%, right? Here's our 3 plus 4 plus 8. And if we did it from 80 to 90, well then there's 9 people right there actually, so it'd still be 9. But yeah, so this graph here is all dependent upon the ranges that you put it in, which changes how it looks and how the graph or how the data is represented.